Okay, this is for 2-3, and this is on modeling real world data with matrices. And I think you talked about some of the operations with matrices last year, but it's been a year, so we're going to review. We're starting from scratch. Okay. First, if you talk about one, it's called a matrix with TRIX, a matrix. It is a rectangular array of numbers or elements. A rectangular array of numbers or elements arranged in rows or columns. If any of you go into computer programming, you'll work with arrays where it's rows by columns. Okay? The author in this section will talk about dimensions of a matrix. When you talk about the dimensions, it's always rows. Rows go across. Columns go up and down. I always think of the southern mansions with the columns outside. A lot of the houses around here will have columns on their porch. So the dimensions are always rows, and the by, they use an X, the rows by columns. And you talked about the dimensions. Okay? For example, if I give you, and I will normally read these first row across, second row across. Okay, so on this one, let's say you have the matrix first row across, and if you listen, you can just write it down. Okay, you don't have to look up here for each one. Just write it down. First row across is 2, 3, 5, -1. Second row across is 7, 8, 9, 0. Okay, now the dimensions, it's always the rows, so you count how many rows are there. There are 2. How many columns are there? There are 4. So the dimensions of this matrix, it's a 2 by 4. Okay? Not the piece of wood. Okay? It's a 2 by 4. Okay? If there would be 3 columns or 3 rows and 2 columns, then it'd be a 3 by 2. Okay? It's always rows by columns. Okay? Okay. Matrices. Are equal IFF if and only if. Matrices are equal IFF if and only if they are identical, element by element, and have the same dimensions. So the only thing that's going to be equal to, the only matrix that's going to be equal to this matrix is another matrix that looks just like it. It's equal element by element and have the same dimensions. Okay? Matrices with the same dimensions can be added. Matrices with the same dimensions can be added. Okay, and they're going to use uppercase letters to represent a matrix. So I'm going to give you an example. Say they want you to find a matrix A plus matrix B. And matrix A is Okay, first row across, 2, -1, 3. Second row across is 4, 6, 5. And remember, these are brackets around them because they're matrices. Matrix B, first row across is -4, 0, 3. Second row across is 1, 0, 2. Okay. Now, the author does a lot of writing. No, you just look at it. Okay, and when you do this, you look at it position for position. This is in the first row, first column. This is in the first row, first column. You just add them together. Okay? And do it by sight. You don't have to write all that stuff down. Just do it by sight. So that's going to be -2. Add them position for position. This is first row, second column. First row, second column. So add -1 and 0. Be -1. Okay, first row, third column, the 3, and the other one, add the 3 and the 3 and get 6. Follow what I'm doing? Just position for position. So add, you'd get 5, you'd get 0, you'd get 7. Okay, so don't do everything the author's doing. Just look at it and add them together. Don't make that hard. Okay. The next thing the author is going to do is they will give you a problem like this. And the directions say find the values of x and y. Find the values of x and y for which the matrix equation, you write that very good. Yep. Oh, sorry. Arithmetic here. Thank you. Okay. When I do that, stop me. Don't just let me keep going. Okay. I'm human too. Okay. For which the matrix equation is true. Okay, so they give you this equation. Okay, now you may have to look on this one. On this one, the first row is y. Okay, the second row is y minus 3. Okay, equals. Put an equal sign because it's a matrix equation. On the second equation, the first element is 4x. Okay, the second one is 2x plus 1. Now, I wish the author had done this. I wish the author would have said parentheses around that. That represents one number. This represents one number. This represents one number. Same thing. This. So basically, we have one or two rows by one column. Okay. So if they're written like that, they're equal position for position. So this is equal to this. So set them equal. Y equals 4x. Okay, and this is equal to this. So set them equal. Y minus 3 equals 2x plus 1. Now you have two equations, two unknowns. Substitution, linear combination, matrices. I would probably do substitution. Y equals 4x, so sub that in. So you'd have 4x minus 3 equals 2x plus 1. Okay? And if you subtract the two x's, you'd have 2x minus 3 equals 1. Do the inverse, add 3 to both sides. Your steps don't have to agree with mine, but your answers ought to be the same. I end up with x is 2. You agree with that? Okay, now put that back in. You can sub it back in up here. Okay, and then you get y equals 8. 4 times 2, so y equals 8. So your ordered pair would be 2, 8. And that would be your final answer. Okay? So when the author's doing that, I wish they had put parentheses, and some of the students might have put parentheses in your book, and that's why. Okay? Okay, then the author goes through some terms that you need. One is the additive identity. Okay, before we do the additive identity for matrices, let's go back and talk about the additive identity for, and when I use a double bar R, okay, that in my class stands for real numbers. A lot of times they will use an R in italics. I can't write in italics. Okay, so I use a double bar R, and most math teachers will. The additive identity for real numbers. Example, 5 plus what number brings you back to 5? 0. 0 is, okay, 0 is the additive identity for real numbers. Okay? Like if I said 9 plus what number brings you back to 9, it's 0. Okay? Now we're going to do the additive identity for matrices. And I'm just going to do it by example. If they gave you the matrix -1, 3, that's the first row, and 2, -4. This matrix is a 2 by 2. It's got 2 rows by 2 columns. Okay? And you say, what matrix do I add to that to bring me back to the original? -1, 3, 2, -4. This basically has to be, because you add it position for position, so it has to be all zeros. If it was a 3 by 3, you'd have 9 zeros in there. Okay, so this is the additive identity for matrices is all zeros. Okay, don't make that hard. Okay, let's look at additive inverses. The additive inverses for reals. If I said 5 plus what number brings me back to the identity? What is it? -5, right? 5 and -5 are additive inverses of each other. In an algebra book, you would see it written like this, and they would use like a lowercase a plus the opposite of a brings me back to 0. Okay, and these are additive inverses of each other. They bring you back to the additive identity. Okay. Okay, now let's look for additive inverses for matrices. Additive inverses for matrices. I'm just going to do it by an example. Let's say the first row across, and this is a 2 by 2. First row across is 6, -2. Second row across is 1, 5. Plus its additive inverse, and it's got to bring you back to the identity 0, 0, 0, 0. Okay, so this has to be -6, 2, -1, -5, and they are additive inverses of each other. They bring you back to the additive identity. Okay, now put this on the, you can see this, put this on the bottom. This would be like matrix A. If you saw this in an algebra book or pre-calc book, it's going to be like matrix A plus, okay, the inverse is going to be written this way, additive inverse. And they're uppercase letters for matrices. And it brings you back to the identity. So that's what the rule would look like in a matrix problem. Okay. Back up here, if you saw this one would be matrix A plus the identity brings you back to matrix A. That's for that one. Okay. Okay, the next thing the author talks about is a scalar times a matrix. A scalar times a matrix. A scalar is just a number, okay, and they're going to use probably the letter K. I'm going to use, my scalar is going to be 5. And if I said, I'm going to do it as an example, if I said my matrix A, and it's a 2 by 2, first row across is 1, 3, the second row across is negative 2, 4. And if they want you to figure KA, they want you to multiply that scalar times that matrix. So usually you just write your scalar out front, and then you just multiply it 5 times each one of those. So 5 times 1 would be 5. 5 times 3 would be 15. 5 times negative 2 would be negative 10. And 5 times 4 would be 20. Okay? And this has a special name. What you're figuring here is called a scalar product. It's called a scalar product. You're just multiplying. Okay, that's a little bit with the identities and the inverses, and you can add any two matrices together as long as they have the same dimensions. Okay, now matrices can be multiplied. Provided the inside dimensions are the same. Okay, what I mean by inside dimensions, if you look at two matrices and you have a 2 by 3, and if you have a 3 by 3, can you multiply them? If these two inside dimensions are the same, yes, you can multiply them, and the answer is a 2 by 3. It's the outside. If I said I had a 4 by 2 and a 2 by 5, as long as those inside dimensions are the same, yes, you can multiply them, and my answer would be a 4 by 5. Okay? So let's look at an example. If I said find AB, and matrix A is, it's a 2 by 2, 2, 0 is the first row, and negative 1, 1 is the second row. Matrix B is 3, negative 2, and 4, 0. Now, it makes a difference. You look at the order that it's written here, AB. So you put them right beside each other. Okay. First, it's a 2 by 2 and a 2 by 2, so our answer is going to be a 2 by 2. Okay. Here's what you have to fill in. Some people like to do that so they know what they're doing, filling in. Okay, now you multiply across rows by columns. Do this with me. You take this row times this column, and it's mental math. Multiply the 2 times the 3 would be 6. Go across with your left hand, down with your right. 0 times 4, 0, and add them together. 6. You agree with that? Okay, stay with this row until you exhaust all the columns. Go across here and down. 2 times negative 2. Multiply them together to be negative 4. Go across here and down here. 0 times 0 is 0. Add them together. Should get negative 4. Go down to this row. Times the first column. Negative 1 times 3. Negative 3. Go across here and down here. 1 times 4 is 4, and add them together. You get 1. Stay with this row and go across, or down this column. Negative 1 times negative 2. 2. And then 1 times 0 is 0. And add them together would be 2. Okay? Okay, that's as far as we're going to get. Okay?